Hello. I got some questions on these three questions and about its limit. The question was, do I need to know the curve of secant, cotangent, and cosecant? Well, if you know those curves, certainly it would be helpful, but you don't really need to know those curves. But you need to know some basic relationship in trigonometry. For example, secant x, we know secant x is related to, well, by definition, equals to 1 over cosine x. You definitely need to know sine, cosine, tangent, okay? You definitely need to know sine, cosine, tangent, and their basic relationship, okay? And cotangent x, you need to know is this a tangent x, 1 over, sorry, okay? It's 1 over tangent x. And you should also know that cotangent is cosine x over sine x. Okay? And of course, you are expected to know cosecant x equals to 1 over sine x. So you need to know these functions, their relationship and how to determine their domains and some special values okay? So let's see how we're going to proceed with the first one. How we're going to do that. Okay, so first of all, this given limit is going to be, if you don't know about secant, then you can write it down as 1 over cosine x. Okay, then you should know that in the neighborhood, right, where x is approaching pi over 2, from larger than pi over 2. If you know the cosine curve, well, you don't know the cosine curve, you know the unit circle, okay? So obviously, when x is approaching pi over 2 from larger than pi over 2, cosine x is approaching 0. The question is this going to be positive? Is it going to be negative? Right? Is it going to be positive or negative? Let's just draw let's draw a picture. I'm going to draw the most basic picture. Okay, I'm not even going to draw the cosine curve. Okay, I'm not even going to draw the cosine curve. I'm going to draw the most basic picture. Okay, so y equals to 0. I'm just going to set it up and start it as a rectangular system and see how we can analyze this from the very basic, okay, that we expect you to be able to do. Okay, so I make some adjustments to the rectangular system. Okay, this shouldn't be too hard. And we know that we understand how angles are measured, right? So if angle measured from, if x approaching pi over 2 from smaller than pi over 2, so when we talk about the angles, obviously the angle is going to be measured a little bit over pi over 2, right? So this is going to be the terminal. This is going to be the terminal, okay? And approaching pi over 2. So this angle. So this angle is approaching pi over 2 from larger than pi over 2. So that's the process we're thinking of. In the second quadrant, cosine is negative. Okay, cosine is negative. So what do we know now? What do we know now? As x approaching pi over 2 from larger than pi over 2, okay, when this happens, right, cosine x is approaching 0, from smaller than 0. So it's a negative. So cosine x is approaching 0 from negative. So 1 over a negative number which is very close to zero. So this piece is going to approach negative infinity, and that piece is going to approach a constant number, because x approaching negative approaching pi over 2 from larger than pi over 2. So overall, this piece, okay, is going to be approaching, is going to be negative infinity, if that makes sense to you, right? So you don't need a curve. You just need some basic, very basic knowledge about trig functions, okay? So let me repeat that. When x approaching pi over 2, from larger than pi over 2, 1 over x is going to be approaching a finite number, which is 1 over pi over 2, right? So this is going to be a finite number. And this quantity is certainly going to approach infinity, but we just need to decide whether it's going to be positive infinity or negative infinity. And because x approaching pi over 2 from larger than pi over 2, as you can see, we demonstrated, so the terminal of the angle is going to fall into the second quadrant. And therefore, cosine x is going to approach 0 from smaller than 0, meaning that this piece is going to be negative. That's how we get a negative infinity. And of course, along the way, we also referred to the 1 over x, right? So that function, 1 over x, we talk about, so let me put it here one more time. I don't think it's necessary. I think you probably got it. If you have questions, let me know, okay? All right, so let's look at the second question. Okay, so before we do the second question, you know what? I'm going to do that function 1 over x to be there anyway. Okay, this is a very basic function that we talk about. It's very useful. Okay, so let me put it here. Okay, so in this picture, right? In this picture, let me bring this over to the other side. All right, what does this picture tell? This picture is useful for us when x is approaching 0 from smaller than 0. Okay, x is approaching 0 from smaller than 0. Okay, in this case, and limit as x approaching 0 from smaller than 0, negative 1 over x is going to be negative, approaching negative infinity, because you see that the output is going to negative infinity. Okay, so that's going to be negative infinity. Secondly, so what if we approach 0 from greater than 0? Right, so this is approaching from greater than 0. Oops. Okay, approaching from larger than 0. So that's the other direction. When x is approaching 0 from larger than 0, that's this limit. Okay, and the output is going to approach positive infinity. Okay, so now at this, you can see clearly, we use this very often. This is really considered the very, very basic. Most of our questions can be resolved by these simple observations. Okay, all right, so with that in our mind, I'm going to put this away. Unfortunately, I have to clear up the arrows, okay, because they're not the same software. And there, but you got it. Okay, so once again, all right, I still have these in front of us. Let's look at the cotangent. Okay, let's look at cotangent. Cotangent, how do we analyze the situation for cotangent? Okay, you don't remember what cotangent is, that's okay, but you certainly know the relationship between cotangent and if you know about tangent, okay, which would be good, okay. So suppose you don't even remember tangent, we're going to use cosine over sine. We're going to use cosine over sine. Okay. So in this case, what will happen is that as x approaching pi from smaller than pi, right? So let me move this just a little bit so you can see more of the screen. So when as x approaching pi from smaller than pi, what does that mean? If we talk about angle measurement, right? If we talk about angle measurement, okay, I'm going to put this picture right here, okay? X is approaching pi from smaller than pi. What kind of angle measurement is this? We're going to measure the angle, okay? Of course, from the standard position, approaching pi from smaller than pi. I think I need a curve. I need the curve. I need a curve right here. Okay, you see that will make it approach. Wait, how come it doesn't let me draw the curve? Oh, never mind. Wait, does it allow me to draw the curve? Let's undo. How did I draw? Oh, okay, this one. There we go. Sorry about that. So we're going to measure the angle from smaller than pi. So this is the situation. Approaching pi from smaller than pi. Okay, all these are very basic trigonometry. So your terminal is like here. That's your terminal because it's before you reach this pi, right? That's what x approaching pi from smaller than pi. Okay. On this quadrant, okay, on the first quadrant, sine, cosine are both positive. On the second quadrant, sine is positive, cosine is negative. So when x is approaching pi from smaller, right, cosine x, okay, approaches what? Cosine pi. It's a continuous function, right? Continuous function, which is a -1. Okay, how about sine? Sine approaches what? Approaches 0, approaches sine pi, which is 0. So you can see the numerator approaching a negative number, the denominator approaching 0, right? And positive, because the second quadrant sine is positive, and cosine in the second quadrant is negative. So this limit is going to be approaching negative infinity because the numerator is negative, denominator is positive, right? Negative divided by positive is negative. Denominator get infinitely smaller. Excuse me, the numerator getting closer and closer to a fixed number. So the whole limit is going to be negative infinity. So that's how we analyze from the basic perspective. All right. So I'm going to clean this up. Let's look at the third one. The third one, okay, cosecant. Okay. Cosecant has a relationship with sine, right? You better know this relationship. 1 over sine equals to cosecant. So we got x over sine x. X is approaching 2 pi, right? And sine 2x, sine x is approaching 0 when x approaching 2 pi, for sure. And the numerator is approaching a fixed number, 2 pi. The denominator is approaching 0. Now we need to figure out what kind of 0 is this, right? So once again, we're going to get to the basic of measuring angles in trigonometry, right? So we're going to measure the angle. How do we measure the angle? We're going to draw, right? Positive 2 pi, but smaller than, so the angle is measured counterclockwise, smaller than 2 pi. So the terminal is about in the fourth quadrant, something like that. In this quadrant, sine is negative. All right? So the numerator, right? Numerator x approaching 2 pi, it's a fixed number. Denominator sine x, right? So as x is approaching, let me write it down here. Copy. So as x approaching 2 pi from smaller than 2 pi, that's where the terminal is. And sine of x is approaching 0 from smaller than 0 because sine is negative in the fourth quadrant. Numerator approaching 2 pi is a positive, denominator approaching 0 but a negative. So the entire limit is going to be, the limit is going to be negative infinity. So that's how we can analyze it from the very, very basics of trigonometry. Okay? And you don't need to know the graphs of cosecant, secant, or cotangent. You just need to know sine, cosine. You really just need the very basic, you need to know sine, cosine. All right? If you know tangent, it would be even better because we do need to use tangent. And arc sine, arc cosine, arc tangent. If you know arc tangent, that would be amazing. If you don't, get to know it, okay? Because we are going to use some arc tangent at some point. Okay, actually very soon. Okay, thank you for watching.